So this is the part A of the syllabus in the IFY. It divides into two parts. The first part will be mainly a revision for those material that you have learned in grade 9. So I will try to go forward in a faster pace. For the second part, we will try to introduce something more complicated. So let's start. In the page 2, so you can see we study the basic structure of an atom. Maybe you can fill in the blanks first. Atom consists of proton, neutron, and electrons, and they all are called subatomic particles because they are smaller than an atom. And the next table is their properties. So of course, what you need to know is for proton and neutron, their mass is more or less the same. That's why we use the term relative mass, because we are not interested in how heavy they are, just a relative value. And for electron, the relative mass is almost zero, so you can say this is negligible masses. But for relative charge, that's more important. For proton is positive 1, neutron is 0, and electron is -1. So this is more important, you need to memorize. And finally is their position. For proton and neutron, they can find in the nucleus. And for electron, so some of you may get it, is move outside the nucleus. But something you should remember is some atoms do not contain neutron. For example, most of the hydrogen atoms actually do not contain any neutron, so you should be careful of that. And as we have mentioned before, the nucleus is a very small object compared with an atom. So you can get the idea is most space in an atom is actually empty. So you get this value is over 99.9% of an atom is actually an empty space. But next, we're going to introduce what is an atom. But for an atom, we can get the idea is the number of protons should equals to the number of electrons, and that's why they are called electrically neutral. We cannot change the proton number easily, but we can change the electron number easily, and the result is ion formed. So you can see if the species carry positive charge, they are called cation, and if they carry negative charge, they are called anion. So you get this idea already before. In order to express the proton number and neutron number, here we introduce a symbol for that like this. First is the atomic number. So you should be careful. The atomic number is actually equals to the number of protons, and the mass number will be the proton number plus the neutron number. So you get the idea. The neutron number, yes, we can find it from the mass number minus the atomic number. In order to express it in a simpler form, we use this symbol. On the right hand side, it includes the symbol of the element, while on the top left side is the mass number, and the bottom left side is the atomic number. Well, in some case, the atomic number can be eliminated because the atomic number can be found from symbol of the element. So you are feel free to fill in the following form and get the answer at the back of the notes. Next, we try to introduce the isotope. So can you see these two elements and point out their difference? From the symbol or atomic number, you can see both of them got 6 protons and of course 6 electrons, because for atom, their proton number should equals to the electron number. But how about their neutron number? The first one will be 6, but the next one is 8. Both of them belongs to the same element, carbon, but they have different number of electrons, and the result will be they got same chemical properties because they got same number of electrons, but the physical properties will be different. So let me introduce. We focus on this word very much. This is same, not similar. So we try to separate them by use physical method because they behave exactly the same in chemical reaction. So this is no point for us to separate them by chemical process because they have different atomic weights. So we can use physical method to separate them. Here we introduce what is isotope actually. First, they are atoms of an element. Now don't forget this term. They are atoms of an element which have same number of proton but different number of neutrons. Some students try to eliminate the first sentence, atoms of an element, and this is not accepted in the examinations. So please be careful. Because the atom is so small and so light compared with our daily objects, so we try to introduce the relative atomic mass is the weight average mass of all isotopes. That means every isotope in the element should be included or they can contribute to the relative atomic mass. So you can see for hydrogen, because most of the hydrogen belongs to 1 hydrogen, so the relative atomic mass is 1. But for lithium, because we have lithium 6 and lithium 7, so after calculate their weight average, the relative atomic mass of lithium is 6.9. Well, this is the simple part, or I can say this is a revision part.